Let us have one last example of t-test of independent means. Let's have this problem. The number of points held by a sample of the NHL's highest scorers for both the Eastern Conference and the Western Conference is shown below. So here's the one for Eastern Conference. Here's the one for the Western Conference. At alpha equals 0.05, can it be concluded that there is a difference in the means based on these data? So pause the video and try to answer this problem. So let us try to answer this problem. So first, we need to make sure that this is for t-test of independent means. Independent means. So we need to have two groups. We have the Eastern and the Western, so we're good. So now we can do our step 1, stating our HO and stating our HA depending on our claim. Our claim here in the problem is that there is a difference in the means. So that would mean the mean of the Eastern Conference is not the same because there's a difference in the mean of the Western Conference. If there's a difference, they're not the same. And this is again for our HA. So the mean of the Eastern is not equal to the mean of the Western. So for the null, the mean of the Eastern should be equal to the mean of the Western. So now that we have our step 1, it's time to do now our step 2 and 3. Steps 2 and 3. So first, we shall now go to data analysis here. And of course, we should first do f-test. Alright. And just looking at what we need for f-test, these ones. So for variable 1, we would select the first one, Eastern Conference. There we go. For variable 2, we shall select the ones for the Western Conference. There you go. The labels are included. Our alpha is 0.05. Output range, we'll just place it here. Everything seems okay. We click OK. So there we go. So now let's take a look at the variances. As we can see, the variance of the Eastern Conference is slower than the variance of our second group, the Western Conference. So we need to do the f-test again. This time, we need the Western Conference as our variable 1. So going back to data analysis, f-test. This time, our variable 1 should be the Western Conference, and our variable 2 should be the Eastern Conference. Then we'll just set the output here, so that there will be space, and click OK. So now that we have set that, let's just remove this one. Alright, let's just adjust, and there we go. We already have our now better f-test. So let's look. We have here the variance now is of the first variable is bigger. So now we have this one here. So now let's take a look at the p-value. So we have here. But as you can see, we have the observations are different because if you're going to notice, let's just take a look back. Here, our Western Conference has fewer data points rather than the Eastern Conference here. So that's why when we go back to this table, the observations would mean the data points or the number of data. The Western has fewer than the Eastern, but the Western is more varied than the Eastern. So here we have the p-value of 0.25. And as we all know, the p-value is less than our alpha. We use unequal variances. If it's greater than, we use equal variances. And since we have 0.25 is bigger than 0.05, we will use equal variances. So now, we go to data analysis. This time, t-test assuming equal variances. Now we click OK. Our variable 1, this one here, should be the variable 1 in our f-test. Therefore, variable 1 should be the Western Conference. There you go. Variable 2 should be the Eastern Conference. Then, we check the labels here. Alpha is 0.05. Our output range should be, let's place it here. There you go. And when everything is okay, we click OK. And there we have it. Let's just adjust a little bit. And there we go. So now let us do our step 4. Step 4. So, based on our alternative hypothesis, this is a two-tailed test, and hence we shall look for the p-value of two-tailed. So, there you go. Fixing it a little bit for our view. Alright. So, we have the means here, we have our variances, and the one that we need to worry about is p here of two-tailed, which is this one. So 0.25, we're going to round it off. So since our p-value is equal to 0.25, what is it compared to 0.05? As we all know, 0.25 is greater than 0.05. Therefore, we shall not reject HO. Therefore, our conclusion will be there is no sufficient evidence to reject HO. So, can it be concluded that there is a difference in the means based on the data? The answer is no. So that's how we do the test of independent means.